Hi, this is Takuma Nakata. I'm an interaction designer based in Kyoto, and welcome to my vvvv beta graphics tutorial. So in today's tutorial, we're gonna learn how to create this kind of spline bizarre thingy by using mouse input. So now I'm drawing the spline based on my mouse position. So I'm going to the left, to the right, and it looks pretty good. And I already did post a tutorial on how to use Spline Buffer, so we're basically using that for today. But I forgot to mention that, of course, Spline Buffer also creates this really nice bizarre mesh. So if you followed my super physical tutorial, you can also apply this to that, because Spline Buffer outputs its strings as a geometry, so which is quite handy to be used. So yep, let's get started. So today's patch looks like this. So we're basically gonna recreate this one. So I can change the color. I'll bring back the render here. And I remember for me, it took a lot of time to figure out how to do the spline thing. And when I found this Spline Buffer node, I realized that it could help me a lot. So I can change the colors here. I'm doing some weird tricks for the background as well, so I'll share how I did that. A little bit less blurring, okay. And then I have this mouse input, so we're gonna recreate this for today's tutorial. So okay, let's get started. So I'm gonna delete this. Oh wait, I'll save it. I always forget this. I'll just save it to my folder. Here. So this one is gonna be called Spline Bezier. Okay, so let's get started. So I'm gonna delete everything, restart vvv from scratch. Oh, by the way, one thing I forgot to mention. So after my last GPU particle packs tutorial, I got mentioned by him, this guy, Andres. He mentioned me that this large PLOI DX11 point cloud reader is already there, and if you're interested in like getting PLY 3D scan data into it, I mean, this is definitely the one you should use, and it's probably really powerful. I had one problem with this patch. I couldn't figure out how I could make it work. Whenever I turn my computer on, the GPU somehow acts weird. It's probably because of my computer, so I hope it works on your side. But anyways, I mean, thanks to Andres for mentioning this, and I can see that it's a really good patch. I just want it to work on my computer. Okay, so let's get started. So first of all, as always, what we need is the renderer and the camera, and have an axis and grid. So this is the result. Here we are. So this is the render, and this is the preview monitor. So now we can change out cameras and things like that. So the first thing we're going to be doing is we're going to add a mouse input. So for now, I'm going to use, there should be 2 mouse input, and I'll use the device window. And what this one does is basically whenever I have my cursor on top of the render, then it shows me the position. If I go in from here, it's -9 to y-axis almost 1, which basically means in vvv here is the -1, -1 for x-y axis. So it's based on the screen render space. So here it's +1, +1, okay? So, and then it doesn't really change even though you rotate the camera. It's because it's based on the pixel position rather than the 3D position. So we're going to be using this. And also I get a spline buffer. This one is from Instance Noodle. So if you haven't installed Instance Noodle, please install this one. And for today, I'll add a fung. So okay, so right now we don't see anything, and that is because we need a Control 3 buffer. So I'll add a dynamic buffer 3D. So it's gonna be this one, dynamic buffer 3D, and then I'll connect this one here. And I'll output the control points per spline and spline count. For today, I think we're going to keep this one 1. And also the resolution. I think I'll higher up the resolution a little bit. 128. Loop, no loop, radius default, I'll just keep it like this. And I'll also make sure that I change this one to tube. Okay, so now we're kind of like getting really close. Just let me open this one up. So next thing we're gonna be doing is we're gonna be using a node called Verlet. This is also included in the instance noodle. So if you haven't installed instance noodle, please install that. I'll put the link below. So what this one is, one of the interesting node that I'm introducing today. What it does, we'll see. I'll just connect this one to wherever I need. So I'll put this one to. Oh wait, I don't need the dynamic buffer because this one outputs a 3D buffer. So I'll put this one above. I'll put this one here. And then what I will be doing is I need a 3D position. Right now mouse input only has X and Y, so I need to add a Z. And to do so, there's this node called XYZ with Z in capital. And there's different types, but choose the one with the Z in capital. So it's going to be this one. What it does, it has a Z input and XY input. So by doing this, you can actually create a 3D vector by Z and 0. I'll just put this one out as well. Okay. So we'll connect this one to dynamic buffer first, and then we'll connect dynamic buffer to Verlet. Oh, and I should output the things from Verlet as well. So Verlet length, in default, this is okay. Verlet selection count, I'm not sure what it is. Damper and spread count. Okay, so for now, our spread count is 1 because we're only going to be using. Oh, okay, we're already seeing the result here, which is pretty great. And then develop. So this is based on this mouse cursor. This Verlet thing sort of like creates a line. It's if you're familiar with vvvv, you might also know about this node called Q. Which basically what it does is basically it keeps caching the position like a vector. So you can choose the amount of frame that you want it to cache. By using this, you can actually do something similar. But Q keeps caching the frame like in raw, but this Verlet thing actually gives you some sort of like curve. So it affects the previous frame and makes it looks very smooth. So that's the reason why I'm using this one. So I think right now the control points per spline is okay, but yeah, I think I'll have to add control. Have to make sure that this Verlet selection count and control points per spline is the same. And this is because so this is the amount of points, like sort of like Bezier points for the splines, and Verlet actually, so it creates sort of like Q from the mouse input. So there's only 3, so vector input, but then Verlet multiplies that. So now it's multiplying 4 times. So in total, it should have 4 spreads out. And that's basically what it's doing. So as you see right now, there's like probably 3 points. It's really hard to see. So well, anyways, this is what it does. And then this damper thing, if I add this one up to 1, then it loses this damper function that we saw when it was lower. So if you lower this down to 0.1, then it goes very, very like dampy. So you don't really see like real curve. So I just keep this one to 1 because I like it to be like this. And then what we're doing here, I added the resolution. Spline count is 1. Okay, so the last thing to do is I'm gonna no, not the last thing. So first of all, I'm gonna amplify this Verlet selection count to 100 because I want 100 resolution. I want longer lines. So now as you see, I got a longer line, and I have to keep drawing to get this guy avoided. but it looks really cool with this line already. Make sure your camera is how do you say, position in the front. If you go to the side, you sometimes lose. And also, if you default spline buffer is in ribbon, but ribbon you have to change the up vector to make it work from the front. You don't really see anything, and you feel like, oh, what's going on? So just make sure that change it this one to tube square. Okay, so now I have 100 points, which made the spline longer. So this is basically what I want to share for today. So using spline buffer and verlet, you can actually create this kind of like smooth spline, which might be really interesting for you, for those of you who might be using like a leap motion and things like that, or Kinect. You can actually generate spline count, Bezier Spline by using this one. I also share how this works with Q, because I already mentioned it. So spread count should be 1 as well. Okay, so what this Q thing does is it keeps drawing, and this is also really nice, but the fact that it's too raw, like it keeps drawing every frame, so it doesn't really look like a really nice curved frame, even though if you're interested in drawing something, this is already quite enough. I would suggest adding a damper in between if you want to use Q rather than verlet. I'll basically just add a damper and spread count to 1. Should make it look a little bit more smooth. If you want to draw, for example, an alphabet like A, this is kind of enough. If you're missing the amount of lines, you just have to add up the verlet section count. Now that I can draw some alphabet. If you're interested in doing this kind of thing, Q is for you, but I'm not going to be using this for today. I'm going to be using this verlet node. Okay. Oh, I think I'm losing. So yeah, this is too long. So make sure like this resolution and verlet section count does matter. So right now, if I add this one up to 300, then the resolution is not high enough. I'm gonna make this one a little bit thinner. High enough so you get this line of like not smooth splines. So in that case, you have to add up the resolution to something higher than 300 to make it look smooth. Okay, but I'll just keep this one to 100 for today, and this one for 28. Okay, so last thing I want to share is so right now, as you see, mouse input only works on the cursor position. So if you rotate the camera, you see that it's not really affecting to the y-axis. And what I want to do is I want to rotate this camera. So add LFO to the longitude. And then I'll make this one rotate in 10 seconds. So if I press R and left click, then the renderer will go back to the default mode. And I want to be able to draw in 3D space rather than just X and Y. And to do so, we'll be using apply transform. I think we'll use the vector, so this one. And then what I'll do, I know there's a smarter way to do this, but I couldn't figure out, I forgot how to do this, so I'm gonna be doing a very stupid way. But anyway, what I'll do is I'll decompose the view, and then I'll put the rotate vector. Then I'll get this rotate vector, and I'll put this back to transfer, but before that I have to do something. Vector 3D join and vector 3D split. Oh wait. So the reason why I'm doing this, so I just connect this one and see what happens. So as you see right now, I got a mouse working in a 3D space. So this is kind of similar to what I wanted to do, but somehow when this one rotates for like 90 degrees, I see that X and Y axis, no, the Z axis is working pretty wrong. So when I go up and down, it's okay, but if I go right and left, right now it's okay, but if now I'm going to the right, but somehow the spline is drawn to the left. And to do so, I'm going to be using these ones. So I'll connect this decompose to vector, delete this one, vector 3D join, and I'll add a -1 to the y-axis, and then the rest I'll just keep it in default, and then I'll connect this one to rotate. By doing this, I got this XY problem solved. So right now I'm here, but whenever it goes, it keeps staying at the same position. If I go down, right, up, now whichever direction I'm looking for from, it's all in a perfect position. So now I can draw on a 3D space. By the way, I couldn't solve it correctly, so when I look at it from the above, it's actually not correct, and I forgot how to solve this. So if any of you know how to solve this, please advise me on the comment. I'll just keep it from this position. So for today I don't need it, but I would like to solve it. So now I got this mouse input brush that I can draw in 3D space. So the rest, what I'll be doing is I'll just add some colors and finalize this visual. So font directional, I'll add some colors to it. For today I'll just keep it, so I don't know what color this is, but I'll keep in this color. And then another thing I'll be doing is I'll add a full screen quad for the background. So I add this, and then I'll remove axis and grid, and then I'll add a frame delay here. And if for those who haven't used frame delay is quite interesting, but on the other hand, it's also a bit buggy. I mean, it's not really a cool way to solve the problem, but what it does is you can read back. Basically, vvvv only goes from up and down, right? So if you want to connect this, I don't know, some values which comes from below spread buffer, for example, this one, I can't really connect. Oh, I can. That's strange. So if I want to connect, for example, some of the outputs from here directly to input, most of the case it's not a good way. Like vvv basically goes from up and down. So if you want to bring something back, you have to use this node called frame delay. And for this frame delay, this one is the frame delay texture 2D. And what it does, I can bring back the render out as a texture to the full screen crowd. In default, you can't, but by using this, you can. So this is what I wanted to do. So now, as you see, I sort of get like texture feedback in my background, which looks pretty good. I mean, this looks pretty nice, but this is not what I want. So I'm gonna add a blur here to the frame delay. Then I'll connect this one here. And by doing this, I can get like a really nice background that is affected by the input. And then I also want to change the color here, so I'll just add HSCV B before the frame delay. Something wrong is happening. Oh, this looks cool, so I just keep it like this. So by doing this, you can sort of have a blurry background for your vision. Ah, this looks interesting, so I'll keep it like this. Okay, so now I get this really fancy visual with the spline. So this is one thing that I wanted to share. So by using flat frame delay, you can sort of have interactive, like real-time background in your visual as well. So yeah, that was it for today. And last, for those who followed my previous tutorial, I'll share you one last trick, which is basically about oh wait, yeah, it's working. So if you followed my last tutorial, I shared about using superphysical, and you can apply this to this spline as well. So because Spline Buffer output things as a geometry, I'll delete quite a lot of nodes here, but I'll keep the camera, no blurring, no fog. I'll delete most of these. Oh wait, where's my camera? I need the camera here. So just delete the rest of these, and then I'll keep this one here, and then bring back the superphone, and I'll connect my camera to the superphysical, and I'll add a preview. As you see already, so what's cool about Spline Buffer is it's because it's outputting a geometry. You can also connect your Spline Buffer to superphysical, and by doing this you can get a really nice lighting, volumetric lighting together with background color and everything like that. So I mean, if you followed my last tutorial, there's quite a lot of potential that you can use, like quite easily implement superphysical into whatever patch you created. And this is the reason why I wanted to share how to modulate superphysical. So yeah, that was it for today. Thanks for following, and see you next time.